Welcome back to The Explainer. Let's jump right into part 2 of our forensic look at digital display tech. We're tearing down 3 massive industry claims today. If you've ever felt that afternoon headache creeping in after staring at your screen all day and wondered, is it just me? Well, you're going to want to pay close attention. We're digging way past the marketing buzzwords right down to the microscopic level of the screens we literally stare at all day long.
So here's our agenda for today. First, we'll hit the digital trap, part 2. Then we unpack lie C3, which is the math trick. After that, lie C4, the safety myth, followed by the X-Factor hazard. Then we're tackling lie C5, fake white light, and wrapping it all up with the physical reality.
All right, Section 1, the digital trap, part 2, looking at the color and light myths.
When you look at how algorithmic lies map to physical realities here, you instantly see the core conflict we're dealing with today. We're so used to blindly trusting the specs printed on the side of a monitor box, right? They promise millions of colors, totally safe viewing, brilliant white light. But our sources argue those numbers completely mask a very different and honestly much harsher physical reality. The algorithms are promising one thing, but the actual physical hardware, it's doing something entirely different to your visual system.
Okay, let's move on to Section 2. Lie C3, the math trick, where we unmask the 255 cubed color depth.
The industry's math tells us we're getting this perfect, 255 cubed additive color. That calculates out to over 16 million true colors. Sounds amazing, doesn't it? Well, the physical reality is that the tiny red, green, and blue subpixels on your screen literally never overlap. They sit side by side in totally separate, distinct spaces. It's kind of like claiming you have a million colors of paint, but you're only allowed to put tiny dots of 3 base colors next to each other and just sort of hope the viewer's eyes do the mixing for you. Because those physical light sources never actually combine in physical space, true additive color mixing at the pixel level is actually impossible. So that massive 255 cubed figure, it's really just a mathematical abstraction of data, not real physical light output.
So the really crucial takeaway from our sources is this. What you think you're seeing isn't an actual physical optical emission of true color. Instead, it's a strenuous neurological illusion. Basically, your brain is being forced to constantly synthesize separate red, green, and blue light spots into a single perceived color. And this constant processing creates a heavy cognitive load that, frankly, your visual system was never biologically designed to handle all day. Your eyes and your brain are just working overtime to stitch together an image that doesn't physically exist in the actual light hitting your retina.
Section 3. Lie C4, the safety myth. Let's look at the subpixel glare reality.
We really have to ask ourselves a logical question based on what the evidence is showing us. If these displays are as perfectly safe as the industry claims they are, why are we in the middle of a global epidemic of unexplained digital eye strain? Why do millions of us suffer from random headaches, blurry vision, and just total visual exhaustion by mid-afternoon? If the light was natural and the colors were perfectly blended, our eyes absolutely shouldn't be giving out on us halfway through the day.
And the hard data in this device audit proves exactly why this is happening. If you look at the measured X-Factor column, you'll notice that even in modern flagship phones and OLED TVs, the hardware overwhelmingly operates at what the source defines as a hazardous level, an X-Factor greater than 3. This hazard isn't some random glitch. It's a fundamental design flaw baked right into the architecture of the display. And yeah, there's a very high probability that this specific quantified hazard is sitting in your pocket right now.
Moving to Section 4, the X-Factor hazard, anatomy of an assault. Let's break this down.
The math here is shockingly simple, but the implications for our health are honestly massive. The X-Factor formula is X equals Z divided by Y. Z is the total area of the pixel, but Y? That's the actual much smaller area that's actively emitting light. Think of it like trying to light up an entire room, but you're only allowed to use a tiny laser pointer. You'd have to make that laser incredibly intense just to compensate, right? Because Y is just a tiny fraction of the total pixel area, those minuscule subpixels have to be driven at X times the brightness just to push enough light out to make the whole pixel look adequately bright to you. And right here is where the biological failure happens. Because the overall screen looks relatively dim on average, your pupil stays wide open. It completely fails to constrict like it should in bright light. This physiological loophole allows these highly concentrated peak energy spikes, which the author really accurately calls energy needles, to just completely bypass your body's natural defenses. They strike tiny clusters of photoreceptors on your retina with alarming intensity. It's exactly like a magnifying glass focusing sunlight to a burning point on a dry leaf.
Just think about that for a second. The screen you're looking at right now is dramatically overdriving its microscopic subpixels. Because your pupil is being tricked by the average overall brightness, your body has to trigger its backup defense mechanism, a continuous, involuntary squinting reflex. The tiny muscles around your eyes are constantly micro-contracting, desperately trying to protect your retina from these intense, invisible energy needles. And that relentless muscle tension, that is the physical root cause of your eye strain.
All right, Section 5, Lie C5, Fake White Light, the impossibility of subpixel white.
Now, the industry teaches us that firing that standard array of red, green, and blue subpixels at full blast naturally equals pure white light. But look closely at the other side of this comparison. Without that dangerous X times brightness overdrive we just talked about, those tiny slivers of red, green, and blue literally wouldn't produce white light at all. If they just emitted light naturally proportionate to their actual physical size on the screen, the output would actually be a dim, muddy, sub-1/3 gray. So that brilliant white you see when you open a blank document, it's actually a dazzling, overdriven glare masquerading as a solid color. It's totally artificial.
Finally, Section 6, the physical reality, hardware over algorithms.
Let's synthesize everything we've uncovered from the physical evidence today. First, 255 cubed color depth is a mathematical trick, not physical reality. Second, true additive subpixel mixing is actually a strenuous neural illusion that places a heavy cognitive load on your brain. Third, these screens are not inherently safe. There's a structural design flaw creating an X factor greater than 3, which directly causes mass visual fatigue. Fourth, the peak subpixel brightness bombarding your eyes is more than 3 times the reported safe average brightness of the screen. And lastly, firing all 3 subpixels produces a dim sub-1/3 gray unless it uses that hazardous brightness overdrive. The industry's algorithms are completely masking this harsh physical reality.
As we wrap up this explainer, I want you to take a second and literally look closely at the device in your hands. Notice the brightness. Notice that slight, persistent strain in your eyes from those energy needles we talked about. And ask yourself, based on the hard physical evidence we've covered today, who actually profits from keeping these mathematical illusions and structural design flaws a total secret from the public? Thanks for joining me, and I'll catch you in the next explainer.